Good day everyone, I am JB Fitisanan, a BSed Science at Abada College, and today I am going to discuss about the atmosphere in its layer. So now, let's take a journey to the atmosphere. First, let us discuss the composition of gases in the atmosphere. Do you know what gases makes up Earth's atmosphere? Just like a warm blanket, it protects us from the cold night air. So our atmosphere surrounds the Earth and protects us from the harmful effect of the sun. Nitrogen is the most abundant gas at 78%. Consumers need nitrogen, but we can get it from the air we breathe. Instead, it comes from the food we eat. Nitrogen fixation. Plants cannot take the nitrogen directly from the air. Nitrogen is removed from the atmosphere through the process of nitrogen fixation. Most of nitrogen fixation is done by the bacteria in the soil. Oxygen is the second most abundant gas at 21%. Humans and animals take in oxygen gas in breathing. Plants produce oxygen during photosynthesis and balance the oxygen content in the air. Other gases make up approximately 1% of the atmosphere. Argon 0.9%, carbon dioxide 0.04%, trace amounts of neon, helium, methane, krypton, and hydrogen as well as water vapor. Although carbon dioxide levels are relatively low, it plays a large role in our atmosphere. Plants use carbon dioxide to make food and release oxygen. Carbon dioxide is a greenhouse gas, which means it traps heat from the sun and slow warms our atmosphere. To sum it up, Earth's atmosphere is composed of about 70% nitrogen, 21% of oxygen, and 0.9% of argon, and 0% is other gases, trace amount of carbon dioxide, methane, water vapor, and neon are some of the other gases that makes up the remaining 0.1%. The atmosphere is about 100 km thick and it's broken down with a layer, and it started with the troposphere. The troposphere is the lowest layer of the atmosphere. It starts with the ground level and extends upward to an average of 14 km. The troposphere is the layer we live in, containing all the air that we breathe. All day-to-day weather occurs in the troposphere. 80% of atmosphere in the troposphere, and it's mostly just nitrogen and oxygen. The troposphere is bounded by tropopause, then stratosphere is directly above it. Propelled aircraft and conventional aviation fly in the troposphere for air traffic. Clouds form in the troposphere, but the cumulonimbus can tower through the tropopause into the troposphere. Second layer of the atmosphere is what we call the stratosphere. Stratosphere is where you find the very important ozone layer. ozone layer helps us protect from the ultraviolet radiation from the sun. In fact, the ozone layer absorbs the most of the UV radiation. The bottom of the stratosphere is around 10 kilometers or 33,000 feet above ground at middle latitude. The top of the stratosphere occurs at an altitude of 50 km or 31 miles. Temperature ranges from an average of negative 51 degrees Celsius near the tropopause to an average of negative 15 degrees Celsius near the mesosphere. Stratospheric temperature also vary with the stratosphere at the season change, reaching particularly low temperatures in the polar night. The stratosphere accounts for approximately 24% of Earth's total atmosphere. The stratosphere contains approximately 19% of the Earth's total atmospheric gases. The lower boundary of the stratosphere is called the tropopause and the upper boundary is called the stratopause. The next layer of the atmosphere is the mesosphere, up to 85 kilometers. The mesosphere burns up most meteors and asteroids before they are able to reach the Earth's surface. The air in the mesosphere is dense enough that the meteors moving through it creates a lot of heat. It is directly above the stratosphere and below the thermosphere. The mesosphere extends to 50 to 85 km above our planet or 31 to 53 miles. The main most important feature of this region are the strong zonal winds, atmospheric tides, internal atmospheric gravity waves or commonly called the gravity waves and planetary waves. Most of these tides and waves start in the troposphere in the lower stratosphere and propagate in the mesosphere. The next layer of the atmosphere is the thermosphere. Within this layer, the atmosphere ultraviolet radiation causes the photoionization and photodissociation of molecules, creating ions. The thermosphere thus constitutes the larger part of the ionosphere. This layer of Earth's atmosphere is about 319 miles or 513 km thick. That's much thicker than the inner layer of the atmosphere, but not nearly as thick as the exosphere. The main components of air in the thermosphere include helium atomic, nitrogen atomic, and oxygen. The thermosphere is the fourth layer of the Earth's atmosphere that absorbs the sun's radiation, making it very hot. The thermosphere puts on the auroras, a dazzling light show caused by colliding of particles. And the thermosphere also where the satellites orbit the Earth. And the thermosphere is a 1 VC layer. The next and last layer is the exosphere, which ranges to 500 kilometers. The exosphere is the uppermost region of Earth's atmosphere and has a clear upper boundary since it gradually fades into the outer space. The exosphere is a tin-like volume surrounding a planet or a natural satellite where molecules are gravitationally bound to that body, but where the density is low, that the molecules are initially collisionless. Different definition place the top of the exosphere, somewhere between 100,000 km or 62,000 miles and 190,000 km or 120,000 miles above the surface of the Earth. Although the exosphere is the most distant layer of Earth's atmosphere, it's the layer that is planet's first line of defense against the sun rays. It is also the first layer to come into contact to protect the Earth from the meteors, asteroids, and cosmic rays.